students, welcome to one more lecture, probably lecture 12 of the PowerPoint sides of presentations of the course Simulation of Business Systems. And we were working on the topics of probability and statistics, and we were almost to the end of the topic, and today we will kind of conclude that major topic today, and then we will move on to other aspect, validation, verification, etc. of simulation systems pretty soon. So today, if you look into today's learning agenda, it will be probability and statistics for simulation. That was the lecture that we were going through. We have already covered the topics of the basic ideas of probability, why probability and uncertainty. We discussed this uncertainty. Then we talked about basic idea of statistics, and we talked about the concept of variability and why statistics is necessary to deal with variability. And we talked about why probability and statistics from an engineering standpoint, why it is needed, okay, and what do engineers do here in this regard, what is so important about the engineering. We talked about the treatment of data, how many ways you can treat the data, what are the specific tools and other aspects of it, and why data needs to be treated. We talked about data coming in two forms, okay, either it is too much of data or too less of data. Okay, we discussed that. Then we, in that regard, we also talked about Pareto diagram and frequency distribution. Pareto diagram is identifying the main causes, that is the 80-20 rule, and the frequency distribution was about grouping of data. Okay, and we discussed why it is needed, and we talked about the visual display called histogram, which is a visual display of frequency distribution. Okay. And today we are at the last topic, which is what we call as the stem and leaf display. Okay. And it is an important tool. Usually this is quite important for simulation people, because it has a uniqueness to it for simulation, especially in identifying input probability distributions. So what we are saying here is that, remember, if you did ARENA, we actually used constant, uniform and those kind of things. So how did we come across identifying those probability distributions for the simulation models? So stem and leaf display is a good way to look at the data and analyze from that. So we already seen the frequency distribution and the histogram, and we saw how it is a good tool, it's a grouping and those kind of things. And but we are now here to look at what are the limitations of the same. So as we said, if you do a quick recap, it is frequency distribution is about grouping the data, into classes, into different classes for identifying. Why do we do this? For identifying trends and patterns. Okay. So you are grouping data, you are grouping the data into different classes, okay, multiple classes, so that you can identify trends and patterns into this of the data. Okay, that's one part, first part. Second part is that we also saw what is a class, okay, class limits and frequency, okay, and frequency are used as part of frequency distribution. So we use classes, class bound limits, frequency, boundaries, etc. are used as part of frequency distribution to obtain details of data in each class. Okay. So, we know that classes, class limits and frequency are used as part of frequency distribution to obtain details of the data in each class. So, from each category how much of data belongs to that category, we uses these tools to identify that. Okay. But in this grouping process, when you are grouping the data into different classes, but in this grouping process original data points get lost, okay, or values are replaced by counts or proportions. So, here what happens is the original data points, the original data values gets replaced by count or proportions. So, the actual value of the data gets lost. So, for different reasons it would be nice to have a diagramming technique, okay. What would this technique do? That do the same function as that of a histogram, but save the original data points. So, if you have a diagramming technique that can do the same function as that of a histogram, okay. Histogram shows you the trends, the trend and patterns in the data, the grouped data. So, it can do the same thing, show the trends and patterns in the data, but without losing the original data values. So, this means without losing the original data values. Okay. That is a technique of this. So, if there is a technique, if a diagramming technique exists, then that would be really nice. Okay. It would be a good tool. This means would be a good tool. Okay. So, that is what we are interested in. Is there a good tool like that? Okay. So, what we are talking about is stem and leaf display, which is a tool like this, which is a tool that do exactly what we wanted to do. So, by definition, okay, the definition is that stem and leaf plot is a data plot that uses part of the data value as the stem and the rest of the data value as leaf to form groups and classes. Okay. So, you are still doing grouping using classes, but you still uses a part of the data value as the stem and the rest of the data value is used as a leaf. That is why it is called stem and leaf. Okay. So, if you think about a tree, you can think about a tree something like this, okay, which has stems like this, okay, and then you have leaves around it. Okay. So, from a central stem you have multiple leaves going in different directions. So, something similar to that, some similar idea like that. Okay. So, the major advantage of this is this technique is very useful for sorting data quickly. Okay. Sorting and binning data quickly, okay, or grouping data quickly. Sorting and binning can be done quickly. Okay. Also helps in grouping the data by stems without losing individual values. Okay. Last one is also helps in identifying the most repeated value in the data set. This kind of information is usually important when we are doing simulation studies, because it is very important, very necessary. So, it is a technique that is very useful for sorting and binning. It also helps in grouping the data set without losing the individual values, and it can also identify repeated values quickly. Okay. So, how, because this looks like a very good technique. So, let us now take a look into what the technique is all about. So, let us take an example, so that I can use this example to demonstrate the stuff. Okay. So, the stem and leaf procedure. So, a set of data is given to you from a certain process, okay, 1821 like this. So, the first thing you need to do is step 1, okay, sort in ascending order, which is smallest to largest, sort in ascending order. Okay. So, that will be 12, 13, then after that it is 21, 27, then it is 33, 34, 35, 37 and 40, 40 and 41. So, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, 11 data points, all right. So, now what we are going to do is, if you have to do then step 2, okay, split into stem and leaves. Okay. In this case, what happens is, if you have a number, let us say 41, okay, then by splitting it in the middle, this will become the leaf and this will become the stem. Okay. So, if you split all the values into stem and leaf, so then you have 12 and 13, those two values. If you split by them, then 2 and 3, this is a leaf, this is a leaf, and both of them have common stem 1. Okay. Split into stem and leaves and write leaf values against common stem. Okay. So, in this case you have stems of 1, 2, 3, 4. So, what you will do is, you will create a diagram like this: 1, 2, 3 and 4, and in the 1 the leaf values are 12 and 13. So, it is 2 and 3, you write like this. Okay. Then in 2 you have 1 and 7. Okay. Then 3 you have 3, 4, 5, 7. So, it is 3, 4, 5 and 7, and then in 4 it is 0, 0 and 1. So, if you take a look into this, this is almost like drawing a histogram. Okay. One way to think about drawing a histogram would be the other way around. So, if you think about this as x axis and this as y axis, this is like drawing a histogram of a histogram like this. Okay. Exactly drawing the histogram like this is what you ended up seeing right here. Okay. If you have to do a if you have to do a frequency distribution, okay, I am going to take 4 classes in this regard, this 10 to 40. So, I will say classes and frequency. So, I will say 10 less than or equal to x less than or equal to 19, then I have 20 less than or equal to x less than or equal to 29, 30 less than or equal to x less than or equal to 39, 40 less than or equal to x less than or equal to 49. If I do this in the frequency, instead of this I will be writing 2, here also I will be writing 2, this I will be writing 4, and this I will be writing 3. So, the histogram is exactly pretty much the same if you look into this, but the only difference is that here you do not know, once you have this information and you plot a histogram of the same thing, which is like this. Okay. 1, 2, 3, 4, you have like 2 and 2 and 4 and 3. When you draw a histogram of this fashion, you are not having the individual values, whereas here the histograms, okay, what we talk about, if you use the look at the values, they actually contain the values, individual values. So, this way you get to know the pattern of the data. You can say that there is a kind of a lump in towards the end without losing the individual observations or the values of the individual observations. Okay. So, here you lose the individual values, here no loss of individual values. Okay. So, that is the main difference that you see in both of the systems. Okay. Now, if you look into this, there is some more thing, okay, that additional information that we need to also understand about stem and leaf. Okay. So, in stem and leaf, each row has a stem, and each digit on a stem to the right of the vertical line. So, what does it actually means is each row has a stem. So, when we wrote the stem and leaf diagram, if you look back, each row, this is a row, okay, row, this is another row, this is another row, this is another row, each row has a stem. So, and here is the stem, okay, and there are the leaves, right. So, each row has a stem and each digit on the stem to the right of the vertical line, okay, line is a leaf. Okay. So, your leaf is this is the leaf, individually these are the leaves. Okay. So, each row has a stem and here is the vertical line, and each digit to the right of the vertical line is a leaf. Okay. That is the first part. Then the stem, or what we call as the stem, is the left hand side column, which contains the most significant digit, the tens digit in this case, in the example. Okay. So, this is the, if you look into this, these are the most significant digit in this case. Okay. So, that is what we are doing here. So, the tens digit is being used in this example, which is the left hand side. The leaves, these are general rules. The leaves are the lists in the right hand side of the stem showing all other digits of the uh, stem. So, for example, what happens is if you have 40, it is easy, you can say 4 and 0. If you have 483, then depending upon how you want to cut, but ideally you would want to cut a stem and leaf like this. So, the most significant digits actually becomes a stem, most significant, and least one, the unit digit, units position will become the leaf. Okay. So, all of the time what happens is whenever you create a stem here, if you say you have data 483, 487, 488, 489, 89 as the data values, then your stem will be 48 and you have a 3, 7, 8 and 9. So, this is the list of digits, okay, for this particular stem. Okay. So, that is what is meant by in this particular case. Okay. So, for any stem, the values opposite in the columns will always be the list of the digits. Okay. So, now let us take a look into another example, it is a larger example. So, that you guys can understand the importance of this once again. So, the large example contains a set of 20 numbers. So, let us look at what are the numbers 29, 44 like this. So, the 20 numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. And the smallest value starts from, in this case I believe is from 12, I believe is 12, right, I think so. And so, let us first sort in ascending format. Okay. We are sorting in ascending format. So, we start with 12, okay, this is done. Do we have any 13 of this? I do not think so, we have a 15, so that is 2. Then we have is 17, I believe, yes, we have 17, okay. So, that is done. Then after 17 we have, there is a 21, do we have a 20? There are 2 21s, okay. So, then you have 21, 21, okay, 2 21s are over. Then you have is 22 is there, 22 is not there, there is a 23 and then there is a 24, okay, that is it. So, then there is a 23, 24, then do we have 25, there is a 25 obviously, okay, only 125, 26, no 26, there are 27, there is 127, 2 27s, okay. So, 27 and 27, 2 27, so 25, 27, 27, okay. Then 28, there is a 28, only 128, and there is 129, only 129, okay. Is there a 30? No, we do not have a 30, but there is a no 31, there is a 32, okay. There is a 32, then 33, there is no 33, is there a 34, there is 134 and there is 2 34s, okay. 34 is there. So, 34, 34, okay. Do we have 35? No. 36, no. 37, now the next one is 39. So, we have 39. Then what we have is 40, we do not have a 40, the next largest one is 42, 42, and after 42 then it is 44, 4, then we have 48, 48, the last left out one is 53. Okay. So, we have sorted every numbers, the 20 numbers are sorted in ascending order 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20. Okay. So, we have all the 20 with us. Now separate to stem and leaf. So, we take the last digit, units digit as leaf and rest as stem. Okay. So, if that is the case, example, if we say 12, this is the leaf, this is the stem. Okay. So, the stems we have is 1, we have 2, we have 3, 4 and 5. Okay. And in 1 the stems are 2, 5 and 7, and in the 2 the stems are 1, 1, then you have 3, then you have 4, then you have 5, then you have 7, 7, 8 and 9. Okay. Then in 3 you have is 2, 4, 4 and 9, and in this one it is 2 and 4 and 8 and 5 it is 3. Okay. So, this is the stem and leaf system. Okay. So, here is your stem, this part, here are your leaves, this part. Okay. Now, if you do comparing it with a frequency distribution, if we compare it with this, I can make a frequency distribution of saying 10 less than or equal to x less than or equal to 19, 20 less than or equal to x less than or equal to 29, 30 less than or equal to x less than or equal to 39, 40 less than or equal to x less than or equal to 49, 50 less than or equal to x less than or equal to 59. Okay. And here in frequency distribution, the frequency that we put here is the count. So, between 10 is 1, 2, 3, the count is 3. 20 to 29, the count is 1, 2, 3, 4, 5, 6, 7, 8, 9. So, 9. Okay. Then the rest case the count is 1, 2, 3, 4. Okay. Then the count is 1, 2, 3 and 1. Okay. So, if you look into this, this here you can think about as a histogram drawn here, okay, without losing the values, but you are still able to see how much of data is grouped into each class. Okay. So, the leaves you can think about it as stem is also a proxy for classes. Okay. That also you should be able to understand out of this, that instead of this class you can think about it as replaced by this stem. Okay. So, looks like a good enough example for you guys to understand and appreciate the importance of stem and leaf. But now, if you want to look into this and why it is important in simulation, then you can see that in a scenario like this, you would say that okay, the time would vary between 50, let us say if this was the time taken to process a particular part, you can say that the time will vary between 10 to or 12 to 53, but not uniformly, because all values are not equally likely. You would probably say that there are 20 values out of this. So, this will give you a frequency, or you can think about as a relative frequency of this. So, that is 9 plus this is actually 20 data points. So, this is the frequency, the relative frequency in this case is 3 by 20, 9 by 20, 4 by 20, 3 by 20 and 1 by 20. Okay. So, then you can say that or you can say there is out of 20 there are 3 values here, there are 9 values here, there is this 4 values here, 3 values here and 1 value here. So, then you can write a probability distribution saying that the values of x, okay, between 10 to 19, you can say that the probability of it is 3 by 20. Okay. Value of 20 to 29 is 9 by 20, something like this. That is one way to write this. But you can also change here, you can make this further, basically saying that the probability of getting 7, 21s and 7s are more. So, there are repeated values. Okay. So, that type of adjustments can be done with the help of a distribution here, whereas in this case you will never know that. You assume that all the any value is possible here, but you cannot know here which values are more possible compared to the other values. So, that kind of detailed information allows you to write a better probability distribution for process inputs. Okay. And this is not a probability and statistics class, as I said earlier, but instead is a topic which is necessary for the students to understand and appreciate the use of it in simulation. So, I am going to ask you guys to do some self study of the topics. So, the major topics are you should study what is a mean. Okay. Mostly the what I simply say is as the sum of all observations, in the data set divided by the sample size, divided by the sample size. Okay. The next one is what we talk about it as the median. This also you need to study the center location of the data set. Okay. If the data is sorted in ascending order, okay. If that is the case, then number 1, if sample size is odd, okay, the median is the middle value, okay. If sample size is even, then median is the average of the two middle values, You can read the details and examples from the textbook. Okay. I am just giving you important information, that is all. Third you need to study is mode. Okay. Mode in a simple sense is the most frequent data value. Okay. If no value appears more than any other, then there may be no mode. Okay. 2. If two values appear more than others, bimodal. Okay. Then there can be trimodal, multimodal, etc. You need to learn and study that. Okay. Then you have what is called as variance. Okay. That is the deviations about the mean. Okay. It is about the deviations about the mean, you have to study that. 5 will be standard deviation. Okay. It is a deviations in the same unit as that of the data value, in the same units. This is actually, here you can think about it as squared. Okay. Units of the data. Then you also need to study something called as quartiles. Okay. These things are all available in a simple probability and statistics textbook, and I would expect you guys to read this and understand and go, because this by spending time on this we will not be able to spend time on our important topics. With this, what we will do is we will say that we have learned enough to be useful statistics and probability information for us to be doing very simple simulation models that we are building in the class. So, thank you for your patient hearing, and please continue to read the books and study things by yourself. Don't just limit yourself to the self-studies topics, just study more probability and statistics. It will be useful to you in simulation. Thank you very much.